Welcome to the EPROM. Well, welcome to the good old EPROM line where I do crazy things. Tonight, after doing a day's worth of assignment work, I've got the phase meter running and opened up, as you can see. Now, I wouldn't recommend doing this unless you are doing it for debugging purposes, but why am I telling you this? If you're watching this channel, I presume you should already know the health and safety bullshit. But anyway, I'm doing debugging, and currently, whenever this card is installed, which is channel A input, it does an overload. Something smells suspicious. What I might try next is removing the logic card for that one and leaving that card in just to confirm it is the input card. I believe it is, as it has relays, which are two errors I reckon that have gone wrong. I've got it going in through channel B at the moment. From the scope and function generator, the scope's showing the frequency I'm pumping into it, let's see. And the function generator is producing it. And of course it's going down the scope cable. And a very bad wiring connection between the scope and function generator, but it works, although it is susceptible to noise and you can end up with some weird shit on the scope screen. So let's see what happens when we change the wave types, just for interest. So that's on 77. Let's change this. Oh, it's definitely destabilized. Interesting. See, this stuff is fascinating. It's stabilised at 59.8, 59.9, 60. Oh, for fuck's sake, stabilise! And so we'll say screw stabling that and change it to triangle, because I've changed it to sine, and well, sine is like a sort of weird triangle wave on this function generator. So we'll go back, so we'll go to square. Square actually is working as properly as it should. No, triangle. 61.1 and back to square, which is not quite perfect. The function generator itself needs a bit of work. So yes, I'm just working out exactly what's buggered, but I believe this is the suspect, and maybe some driver circuitry for it. Could even be a dodgy cap. I've got my ESR meter out and I'm measuring. So I'm going to power this off, take out the logic card that links to this, and see what that does. Might just work, see. Always experiment. These things are designed to be repaired, which means I can get this back up to full operation. Although I won't have a clue on how to calibrate it, even with the manual telling you how. It's not exactly in plain English. It's in sort of techie mumbo jumbo. And yes, there is such thing as techie mumbo jumbo. AKA how they tend to lay out the manuals for these things. Is that what they teach you as an electrical engineer? Just how to understand loads of weird, like, lawyer mumbo jumbo, where it's all these weird terminologies and that. It's not very clearly stated, basically. But doing some research on this, backboard's the power supply, so don't get your fingers in there. Forgotten what that board does, but it's also important. Well, they're all important. That one is like, can be that one or that one, and it's some kind of amplification-y thingy. That's your display mount board, and that's, I've forgotten what that one does. Very good. And that one's also, I've pretty much forgotten what they do. I did read it. But these are like your input stages. This one and this one. This is like the digital logic pre-amplification stages, which have this hybrid awesome ceramic white IC with a gold lid on top, and these are just like phase detection board and current source. So I reckon do another swap round and I'll report back what happens. Right, that pretty much proves that it is in the input board. Here's the amp board, and there's that lovely hybrid chip I was talking about. That is art. I cannot tell you how beautiful that is. Fascinating little circuit board. Ah, there's a little transistor mounted to the sink. Is there anything on the other side? Just a screw hole mounting it there, so it's obviously a power transistor. So we get plugging this circuit board back in. There's two of these in this, same as the other ones. And continue with the debugging. Okay, I've been doing some basic debugging and I couldn't get any life out of the relays. Nothing seemed to connect up on either of them, so could be a bad one there. That doesn't register on the SR meter, that cap. If it's not a cap and you know it's not, please mention it, but as far as I can see, it's a cap. Here's a close-up. Come on, I know you can do close-up. There we go. Now we can see what I can see. Give you a good brim of the board. Most of the caps seem alright. One that does get me a bit concerned is that one due to the ESR, and one of these has a bit of a high one but not dangerous. I need to check it on the capacitor's card, which I still need to fully understand. Lovely gold plated contacts. I want to see it running again because I do. So I'll just plug that in the back. Always unplug this stuff when working on it. On. And now it's picking up what's in there, and we've got focus. There we go. The camera can see through the display better than the human eye can. Probably not all that surprising, to be frankly honest. So yeah, channel A is dead, but channel B works. This thing is fully recoverable somehow. I've just got to figure out what's broken on that board. I did find the coil though. I was doing the multimeter and continuity. I'm going to see if I can find a data sheet for those relays, so I can get an idea of exactly their pinout, what should be connected, when there's power and what shouldn't be connected, their voltage, because none of that seems to be marked on them, or at least in the form that I understand, because we are talking about a circuit board which is about a little over 30 years old. So yeah, things were done a little differently back then. We're no longer on the 70s value. Let's knock it to phase. There we go. Now it goes to the other relay. There we go. That's good focusing. So, from me, for now, I hope you enjoyed, because this is utterly fascinating. Hey, I've done bloody days worth of assignments. I'm entitled to doing this shit. Thanks for watching. You shall see me again soon when I upload this video, which will probably be at an end date because I've got a whole backlog of current recording of this, of videos that need to be compiled and uploaded, and I want to get them done. But I keep finding I want to make more. Anyway, that's enough rambling for now. You'll get bored, if that's possible. So, oh fuck's sake, stupid bloody focus. Can you tell me it does respond to the focusy button, you just have to hold it. See you on the next see ya. The manual may be confusing at times, but at least it's got schematics. Here is the suspect card, A1 in this case, not A2, but it's the same card. And here's the schematics of with it combined with the other card. So I've got to figure it. That's the other card. So I've got to figure out which one's which. But we're looking for the input stages. We've got some oscilloscope things too, which might be worth checking out actually. What are they? How the hell am I supposed to probe these? I'm not sure. But potentially, yeah, it is a cap and it seems to be buggered, so Replacement will be required. It is 100 volts, 200 volts. Must be clean handles. What, you must wash your hands or something? I don't have clean room conditions, so if that's what's required, well, I can't provide that. So we shall see you next time. This could be potentially a parter, but this is definitely going in the system restoration sections, because I see there's good chances of getting this machine up and going. Here we go, the preamplifier. It's all in block diagrams. It's all labelled. Look there. Probably saw that, but I didn't because I'm stupid like that. I'm Wallace. I'm the dumb inventor. I know what I know. I'm good at what I know, but I get confused by everything in everyday life, and the camera chip's about to run out. So, see ya! Can't do it here, but I think that diode is the cause of the whole problem, because it allows voltage both ways. Although there's a huge voltage drop in reverse, something as simple as that can cause that. And also this cap's gonna need replacing. It's buggered. So that's debugging pretty much done. It's gonna be a while before actual repair can be implemented. Interesting video, this one, I reckon.